Hello students, today I am going to teach you second part of chapter number 1, chemical reactions and equations. Students, in my last lecture I explained you about what are the precipitation reactions and their examples. One of you students also asked me how to know which element is more reactive and which one is less reactive. Particularly in this type of reactions such as displacement reaction, more reactive element displaces a less reactive element. So here you can see zinc is more reactive than copper. But how will you know if we have some other examples? For this purpose, I am giving you a table. This is called reactivity series of metals. On the top is potassium, which is most reactive. At the bottom is gold, and there is one more, platinum is also there down there, which is least reactive. Students, as you can see, sodium here and calcium is here. Okay, so it means that sodium can displace calcium easily, but calcium, which is less reactive than sodium, calcium can never displace sodium. Similarly, magnesium can displace aluminium, can displace zinc, iron, lead, hydrogen, copper, mercury, silver, gold and platinum. But reverse is not possible. Okay, how you can memorize this? So there is a shortcut trick. I am giving you this shortcut trick so that you can memorize this reactivity series in easier manner. For potassium, I use please. For sodium, stop means S is taken from sodium. Okay, so please stop calling Ca, calling me for magnesium, A for aluminium, carbon, cute, zinc for zebra, iron in the, okay, lead library, H hydrogen, copper call, manganese again me, something silver, good gold, please for platinum. So please stop calling me a cute zebra in the library. Hydrogen, call me something good, please. Okay, with the help of this shortcut you can memorize this reactivity series. Okay, so today we are going to start oxidation and reduction reactions. Students, the concept of oxidation and reduction is based on addition or removal of hydrogen and oxygen. So we can define as oxidation is a chemical reaction. Oxidation is a chemical reaction which involves the addition of oxygen. Okay, the simplest definition of oxidation is addition of oxygen to a substance, or it may be defined as the removal of hydrogen from a substance. So oxidation can be addition of oxygen or it can be removal of hydrogen from a substance. Now reduction. Reduction may be defined as the addition of hydrogen to a substance or removal of oxygen from a substance. Reduction is exactly, or it is just opposite of oxidation. So if you remember oxidation, then you can reverse the definition. It will be the definition for reduction. Okay, oxidation is addition of oxygen and removal of hydrogen, while reduction is addition of hydrogen and removal of oxygen from a substance. An overall reaction which involves both oxidation and reduction simultaneously is called oxidation reduction reaction, or it is simply called as a redox reaction. Okay, there are some reactions in which oxidation and reduction takes place simultaneously. Those reactions are called redox reaction. Now another definition is oxidizing agent, oxidizing agent. What an oxidizing agent? A substance that oxidizes another substance and itself get reduced. Okay, it is called oxidizing agent. Reducing agent is just opposite of oxidizing agent. A substance that reduces another substance and itself it get oxidized. With the help of these examples, on the following example, you can understand which one is oxidizing agent and which one is a reducing agent. Here is an example of redox reaction which involves loss and gain of oxygen. Means loss of oxygen is reduction and gain of oxygen is oxidation. Yes, so in this reaction where zinc oxide reacts with carbon and forms zinc and carbon monoxide. Here you can see in the above reaction ZNO, zinc oxide, has lost oxygen and form zinc. So zinc oxide converted into zinc and losing one oxygen. So losing oxygen is called reduction. We can say that ZNO has been reduced into zinc. ZNO is getting reduced into zinc and carbon has gained oxygen. So carbon has gained oxygen from here and it formed or it got converted into carbon monoxide. So here we can say that carbon has been oxidized. Carbon gain oxygen to form carbon monoxide. We can say that carbon has been oxidized. Now ZNO has given oxygen. ZNO is giving oxygen to carbon. We can say that ZNO is the oxidizing agent because it causes oxidation of carbon. And here zinc oxide has been reduced. So oxidizing agent is the substance that oxidizes another substance and itself getting reduced. Here zinc oxide is getting reduced. So when it getting reduced, it is called as an oxidizing agent. Similarly, carbon has gained oxygen, means carbon undergo oxidation. So we can say that carbon is a reducing agent. Okay, so reducing agent itself get oxidized. So here carbon is oxidized. That's why we can say that carbon is acting as a reducing agent. Similarly, you can go through these examples and try to understand by yourself. Okay, you can pause the screen and try to understand redox reaction involving gain and loss of hydrogen. We know that gain of hydrogen is reduction, yes, and loss of hydrogen is oxidation. So try to understand. Okay, there are two examples. The first one you try to understand and the second one I am going to explain. MnO2, which is manganese dioxide, when reacts with hydrochloric acid, it forms manganese chloride, water and chlorine. In the above reaction, hydrogen, or we can say HCl, is getting converted into chlorine. Hydrochloric acid getting converted into chlorine. So we can say that hydrogen is removed. Hydrogen is removed from here and it got converted into chlorine. So we can say that HCl has been oxidized to chlorine. Okay, HCl, this one getting oxidized into chlorine, and here MnO2 losing oxygen. Okay, it is losing oxygen and converting into MnCl2. MnO2 has been reduced to MnCl2. Okay, because it is losing oxygen, that's why we can say that it is getting reduced. And what it is forming? It is forming MnCl2. So we write or we say like this: MnO2 has been reduced to MnCl2, while HCl is getting oxidized to chlorine. Okay, this is the same thing. Okay, better I delete this one. Okay, there are some other examples also. You can go through this example. This one I explained you already. So the second one, no need to um, consider. Try to consider this first example. Okay, in our next lecture I will explain you about endothermic and exothermic reaction. Okay, so try to prepare your notes in your notebook and send me a pics of your notes. Thank you very much. If you have any problem, you can ask me. Thank you.